Hello guys, welcome to our discussion of normal distribution. Normal distribution is one of the most important distributions in statistics, if not the most important. It is important because of its usability and applicability in the area of statistics. So today we're going to look at how to use a probability density curve to describe a normal population. We'll use the normal curve to describe a normal population, and we're going to find areas under the normal curve. We're going to find the z-scores corresponding to areas under the normal curve. Okay, so the normal distribution has a bell or symmetric shape. Most of the data are clustered around the mean or the center. The lower half of the curve has a probability or area of 0.5. and the upper half has a probability of 0.5. So the total area under the curve is 1. Okay. Properties of a normal distribution. It has one mode in the center right here. It is symmetric. We already said that. It's symmetric and has a bell shape. The mean is the same thing as the median and also the same thing as the mode. Okay. We see that this is bell shaped, which means that majority of the data is clustered around the mean. We have what we call the empirical rule, which tells us the percentages of the data that are clustered within a specified amount of standard deviations. For instance, 68.3% of the data are within one standard deviation of the mean. 95.4% of the data are within 2 standard deviations of the mean, and 3 standard deviations contain almost all, which is 99.7% of the data. Okay, the standard normal curve has a mean of 0 and standard deviation of 1. As you can see right here, the mean is in the middle and the standardized, so the mean is 0 and the standard deviation of 1. Okay. So going further down, we can see the illustration of the empirical rule. You can see within standard deviation we have 68.3%. If you add 34.13 and 34.13, that gives you 68.26. So within one standard deviation of the mean, the upper one standard deviation and the lower one standard deviation. Okay. So you can also see within 2 standard deviations we have 95.44% of the data, and then within 3 standard deviations we have 99.72% or almost all the data. Okay, so we're going to illustrate further this using this table right here. We have the mean in the middle. If we standardize, the mean becomes 0. Okay. Then we have one standard deviation above the mean and one standard deviation below the mean. Okay, that's why it has negative. They're below the mean. So if we standardize, as mentioned, the mean becomes 0 and the standard deviation is 1. 1 above the mean, 1 below the mean, 2 above the mean, 2 below the mean, and so on. So let's just give this example. Use this example. We have a mean of 70 and the standard deviation of 5. So in the middle we have the mean of 70, and then one standard deviation above the mean will be 75 because we just added one standard deviation to the mean, which is 5 plus 70, which is 75. Then one standard deviation below the mean means subtract 5 from the mean of 70, so we get 65. So 2 standard deviations above the mean will be 80 because we are adding 2 standard deviations, which is 10. Then 2 standard deviations below the mean will be 60. So you're subtracting 2 standard deviations of 10. Then 3 standard deviations above the mean will be 85. 85, and here is going to be 55. Okay, so you can see that the z-score of -1 is equal to a raw score of 65. A z-score of -2 is equal to a raw score of 60. If you go up, you're going to see that the z-score of positive 1 corresponds to a raw score of 75. A z-score of 2 is the same as the raw score of 80. And this is how we get this. The z-score formula is equal to the raw score, x in this case, minus the mean divided by the standard deviation. Okay, so that is, for instance, if we want to change 80 to a z-score, so x becomes 80 minus the mean of 70 divided by the standard deviation, which is 5. Okay, so that gives us 10 divided by 5, which is equal to 2. Okay, so a raw score of 80 is the same thing as a z-score of 2, as we have just found right here. Okay, so if we go down, we're going to see further illustration of what we talked about, the standard deviations and the percentages for the empirical rule. Okay, now going further down, we can see that at any point we can change area to z-scores. If we go up here where we have this, you can see that the area to the left of z-score of 0 is 50%. Okay, so this is the z-score is 0 and the area to the left is 50% or 0.5. So we can find the area to the left of any z-score if we know the z-score. For instance, I can decide to find the area to the left of this z-score is equal to 1. So it means that I'll come right here and find the area to the left. Okay, so that is what we are going to try to look at. We're going to use TI-84 plus to do that. Okay, so for instance, we are asked to find the area to the left of z is equal to 0.56. Now since z is positive, remember z can be positive if it's on the right side of if it's higher than the mean, or negative if it's less than the mean. So in this particular case, z is a positive 0.56. So we want to find out the area that is to the left of this z-score. Okay, so to do that, we are going to use the TI-84 plus, and this is how we'll find this. We're going to use normal CDF. Normal CDF calculates the area from the left to that particular z-score. So in this case, we are going to have this. This is what we are going to have. We'll have the curve right here, and then we'll have the mean right here. The mean standardized is 0. Then 0.56 will be somewhere here on to the right of the mean. That's 0.56. So we're looking for this whole area. Okay, this is 0.56. So to do that, we are going to use normal CDF, and we have mean, max, mean, standard deviation. So the z-score is 0.56, and we are going to do this to the left. Of course, for you to use TI-84, or TI-84 always calculates to the left of the z-score. The minimum, whenever you are finding the area to the left, the minimum is -1e99. That's what you put in the calculator. So the maximum is 0.56. The mean is 0 and the standard deviation is 1. Okay, standardized. So anytime we are using the z-score, know that the mean is 0 and the standard deviation is 1. Okay, so we are going to go to start. To the calculator and turn it on. So to find the normal CDF, we are going to go to second verse. Most of our distributions are found here. So number 2 is normal CDF. So you can see the lower, have to put in the lower, which is the minimum right here, and the maximum, which is the upper. Okay, let me clear this and show you how we do this -1e99. So I have to type in -1. Then E is right here, so I have to put the second comma button. Then I have to type 99. Then the upper is 0.56, which is the maximum. 0.56. Okay, the mean is 0 and the standard deviation is 1. So I will do that. I will paste, enter. So it's 0.7. Let me put it right here. So this is equal to 0.712. Okay, so that is the area under the normal curve to the left of z equals 0.56. Okay, now I can also find the area to the right of z equals -1.26. Okay, now this one is to the right. Okay, now if it's to the right, it means that the minimum is -1.26 and the maximum is 1E99, because we're going to the right right now. So what this is going to mean is that we will have a curve like this. We have the mean, and z is negative, so it's to the left of the mean. So this is where z -1.26 is gonna be, right here. This is left of the mean. So we are now saying find the area to the right of z. So to the right means everything to the right from that particular z. Okay, so that tells me that the answer is going to be more than 0.5, because this half is 0.5 then plus this area. So we're going to do the same thing. We're going to go to second verse, and we're going to select number 2. And now we are starting from the z-score to positive infinity. So our minimum is going to be -1.26. So -1.26. And then the upper is 1E99. Okay, the mean is 0 and the standard deviation is 1. Again, anytime we are given the z-score, it means that it is standardized. So the mean is 0 and standard deviation is 1. So go down and paste, and then this is the probability that we have. Okay, so normal, what we just did, let me just write the answer. I already know how to do this. Well, let me write it. Normal CDF. I typed in -1.26, 1E99, 0, 1, and that gave me 0.896. That is the area to the right of z equals -1.26. Okay, so lastly, we are asked to find the area between z equals -0.8 and z equals 1.26. The same thing we're going to do. The minimum is going to be -0.8 and the maximum is 1.26. Okay, so we're going to go to do the same thing. Excuse me. So we have second verse, select number 2 again. The lower is -0.8, and then the upper or maximum is 1.26. 1.26, and then we enter and paste. So we have this as the final answer is 0.684. Okay, 0.684. So that's how we find the area to the left, to the right, and between two z-scores. Okay, next time we're going to look at how we find the z-scores if we're given the area of a particular section of the normal curve. Okay, so till then, have a very wonderful time.